Hello, my dear robotics developers, and welcome to a new video. In today's video, we're going to talk about custom messages in ROS2, what they are, when you might need them, and how to use them both in Python and C++. Whether you're building simulations or real-world robots, custom messages are essential when standard ones don't quite fit your needs. So let's get started. So what exactly is a custom message? A message in ROS2 is a data structure used to exchange information between nodes. While ROS2 provides many standard messages, sometimes your application needs to exchange more complex or specific data. That's where custom messages come in. They give you the flexibility to define exactly what your application needs, but don't overuse them. If a standard message like geometry messages or sensor messages does the job, prefer that for interoperability. But that was all for the theory. Now let's see how things really work in practice. Let's now go through the steps to create a custom message in ROS2 from scratch. Step 1. Create a new package to store your custom messages. In our case, the package will be called MyMessages package. To create the package, you can use the ROS2 package create command with the build type CMake flag. Step 2. Move inside the newly created package and create a folder called MSG. It's inside this folder that you can create and define your custom ROS messages. For this tutorial, we will create a message file called sphere.msg, which will contain information about the position and the radius of a sphere. The message will contain an header field for providing time information to the ROS system, a geometry message point field for the coordinates of the center of the sphere, and a float64 field for radius. Be aware that the names of the fields are customizable and you can choose whatever names make more sense for your message. For step number 3, we need to edit the CMakeLists.txt file to include the message generation logic. To do so, you'll need to specify the packages that your package depends on using the command findPackage. In our case, we need to add standard messages, geometry messages, and ROS-IDL default generators. You also need to add the command ROS-IDL generate interfaces to make sure the ROS building system will be able to find and build your custom message. Step 4. Update your package.xml to include build and execution dependencies. To do so, add ROS-IDL default generators as a build tool dependency, standard messages and geometry messages as standard dependencies, and ROS-IDL default runtime as an execution dependency. Lastly, you have to specify that your package is a member of the ROS-IDL interface packages using the member of group flag. Step 5. Finally, build your workspace with Colcon build. Once done, source the setup file inside the install folder and your message is ready to be used. To verify that your message has been successfully built and is available in ROS2, you can use the following command: ROS2 interface show MyMessages package /message/sphere. This will print out the structure of your custom message and confirm that everything is properly set up. Let's now look at how to use this message in Python. I've already created a package called Python ROS package with 2 nodes. Python pub node, which publishes the sphere message once per second, and Python subnode, which subscribes to the topic and prints out the message content. Let's first look at the publisher. As you can see, we import the message using the instruction from my message package.message import sphere. Then, inside the class, I create a publisher of type sphere and publish the message in the timer callback publish sphere. Each message includes a timestamp, a center point, and a radius. Now let's look at the subscriber, which is very simple. It just subscribes to the same topic, receives the message, and prints out the content. To make sure your package is properly set up, you just need to add the execution dependency on myMessages package in the package.xml file. That's it for our Python package. Let's now demonstrate the nodes in action. First, I launch the Python Publisher node. Then, I run the Python Subscriber node. As you can see in the terminal, the subscriber correctly receives and prints the sphere messages published on the topic, confirming that our custom message setup works as expected. Let's now do the same thing, but in C++. I created a new package called cpp ROS package that contains two nodes. One is a publisher called cpp pub node, and the other is a subscriber called cpp sub node. Before diving into the implementation, let's talk about how to correctly import and use the custom message in C++. To use the sphere.msg in your C++ code, you need to include the generated header file using the instruction include myMessages package /msg/sphere.hpp. This header becomes available after you build your workspace, and it's required for every node that wants to create, publish, or subscribe to sphere messages in C++. Next, you must properly configure your CMakeLists.txt and package.xml files. In CMakeLists.txt, ensure the following. First, add the dependencies on myMessages package using the find package command. Then, declare the two executables as you would do for any standard ROS node using the add executable command. Last, link the message dependencies to the executables using the amend target dependencies command. In your package.xml, simply add the dependency on the package containing the custom message. Now let's look closer at how the nodes actually work. The cpp pub node has a timer and a publisher class attributes. Notice that the publisher is of type myMessages package message sphere. The timer activates the publish sphere method 1 per second, and inside this method, the class creates a sphere message, fills in the header timestamp, center coordinates, and radius value, and then publishes it over the ROS network. Looking at the subscriber node, the cpp subnode subscribes to the same topic and prints out the message contents, a timestamp, XYZ of the center point, and the radius. Let's now show that it actually works. First, I start the cpp pub node. Then I run the cpp subnode. On the terminal, we can see that the subscriber receives and prints the sphere messages exactly as expected. This confirms the full round trip of publishing and subscribing with a custom message in C++. So now you've seen how to create a custom message and use it in both Python and C++. These tools are essential when building serious robotic systems, especially when working with simulation or complex data structures. You will find a link in the description to the GitHub repository with all the code shown in this video, so you can try everything out on your own. To wrap up, here's a question for you. Can the Python subscriber listen to the messages published by the C++ publisher, and vice versa? The answer is yes, and that's one of the great things about ROS2's middleware architecture. If you found this video helpful, please consider liking and subscribing. Also, let me know in the comments what topic you would like to see covered in future videos. Your feedback will help shape the next tutorials. Thanks for watching and see you in the next video.